Welcome back to The Explainer. Today, we're unpacking a massive leap forward in the software development world, Oracle's Java 26 release. Seriously, if you're building, maintaining, or scaling distributed applications, this is an update you literally cannot afford to ignore. Java 26 is laser-focused on making the platform absolutely ideal for modern, cloud-native enterprise development. We're going to break down exactly what this means for you and your tech stack, making these complex updates crystal clear. Let's get into it. Okay, let's dive into this. There's a quote that perfectly captures the essence of this release. The Java community is moving towards making Java ideal for modern-day enterprise application development. You see, this update isn't just a laundry list of syntax tweaks or, minor bug fixes. It's a fundamental shift. We're looking at an evolution specifically tailored for cloud-native apps, applications that need to be deployed frequently, rapidly scaled, and instantly started or stopped. To make all of this super easy to digest, we've organized the key features into 3 core thematic buckets to show how they impact the software development lifecycle. First, security and code integrity. Then, cloud-native performance boosts. Third, better developer experience. And finally, we'll wrap up with a look at the road ahead. All right, starting with Section 1, security and code integrity. Oracle is making some bold housekeeping moves to secure the platform, and that starts with cleaning up the past. And this brilliantly illustrates how Oracle is reducing maintenance burden and dropping that old technical debt. Historically, applets were the standard way to run Java inside web browsers, right? But modern browsers dropped support for them ages ago because of performance and security issues. While the API was officially deprecated back in Java 9, Java 16 finally rips the Band-Aid off. It's completely removed, gone. This streamlines and secures the platform immensely. Sure, it's only going to affect very old legacy apps, but man, it's a huge step forward for the ecosystem's overall health. Now, if you maintain legacy code, especially if you're using older serialization libraries, dependency injection frameworks, or mocking tools, you really need to pay close attention here. As Java developers, we use final variables to guarantee that values can't be changed after initialization. It's absolutely crucial for immutable objects and JVM optimization. But historically, clever frameworks could use deep reflection to bypass this and just modify final fields anyway. Well, not anymore. Starting in Java 26, the JVM is going to issue warnings when your code tries to modify a final field using deep reflection. And while it's just a warning right now, the writing is on the wall. Stricter encapsulation is coming for sure. So you need to audit your libraries today and start migrating toward constructors, builders, or records. Security management is also getting a massive usability upgrade. If you've ever dealt with certificates or keys, you know they're usually stored in PEM format, which is just a compact text-based format for binary security data. In the past, reading and writing PEM files meant dragging in third-party libraries, or worse, writing complex boilerplate code yourself. But with the second preview of the newly proposed PEM API in Java 26, this capability is built directly into the standard Java SDK. No external dependencies required. It makes securing your applications significantly more pragmatic and honestly, just way more streamlined. Moving right along to Section 2, Cloud-Native Performance Boosts. This is where Java 26 dramatically targets latency and startup time for the modern cloud era. So, why does this matter? Well, it's all about how your microservices talk to each other. The introduction of HTTP/3 support in the HTTP Client API is a real game changer. Think about it. HTTP/1.1 and HTTP/2 rely on TCP. And the big problem with TCP is that a single dropped packet can delay all streams sharing that connection. It's a frustrating bottleneck known as head-of-line blocking. HTTP/3 fixes this entirely. By using the Quick Transport Protocol over UDP, streams can now progress completely independently. Plus, it features automatic protocol fallback. If the target server doesn't support HTTP/3, it just seamlessly falls back to HTTP/2 or 1.1. For network-heavy cloud applications, we're talking about drastically reduced latency here. Let's see how this builds on startup performance. When a Java app starts, creating certain objects is computationally expensive. Ahead of time, or AOT, object caching acts kind of like meal prep for the JVM. It identifies these expensive objects during startup, stores them in a cache, and then simply loads them from the cache the next time the app starts. It's brilliant. Now, previously, this was limited to specific configurations, but in Java 26, AOT caching is available for any garbage collector. You no longer have to compromise. You get those lightning-fast startup times even if you prefer a low-latency collector like ZGC. And speaking of garbage collectors, the default G1 garbage collector is getting a fantastic under-the-hood upgrade. G1 constantly tracks object reference changes to perform its cleanup. Historically, this tracking required significant synchronization overhead between your actual application threads and the background GC threads. Well, Java 26 internalizes improvements that reduce this synchronization requirement. By optimizing how reference changes are tracked, the application threads spend much less time waiting synchronously. So what does that mean for you? It means they spend more time executing your actual business logic. This is a massive throughput win for apps with high allocation rates. And for sheer computational power, we have the 11th incubator of the Vector API, introducing SIMD, which stands for Single Instruction, Multiple Data. Normally, a processor handles one value at a time, but the Vector API allows Java to perform the exact same operation on multiple values simultaneously. It brings Java incredibly close to native code performance, all while maintaining portability across different CPU architectures. If you're working on computation-heavy workloads, stuff like machine learning, image processing, or financial calculations, this feature is an absolute powerhouse. Next up, let's look at Section 3, Better Developer Experience. These are the quality of life enhancements that will really ease the daily grind of writing code. Think about this for a second. Why load objects your app never uses? It sounds crazy, right? But in traditional Java, class constants are created the moment the class gets loaded, regardless of whether your application actually needs them at that exact moment. It wastes memory and drags down your startup times. To fix that memory waste, developers used to write incredibly complex, unreadable boilerplate code to create constants only when they were needed. But now, Java 26 introduces the second preview of lazy constants. This mechanism is now entirely built in. The JVM will automatically create these constants objects only when they are first used. So you get all the benefits of faster startup and lower resource usage entirely out of the box with zero messy custom code required. How great is that? Next up is the sixth preview of structured concurrency, which is a brilliant addition from Project Loom. Traditional multi-threading can honestly feel like managing a chaotic crowd of people. Coordinating threads, handling individual failures, and cleaning up resources is notoriously complex. Structured concurrency changes the whole paradigm. It treats multiple related tasks as a single, unified team. If one task fails, the entire scope is aware and the other related tasks are automatically canceled. This prevents the JVM from doing wasted computational work and just makes your concurrent code vastly easier to read and maintain. Now, what's really interesting here is how Java 26 simplifies conditional logic. Pattern matching has been making Java code cleaner for a while by reducing manual type checks and casting, but previously it only worked with reference types. While in the fourth preview included in Java 26, pattern matching now supports primitive types like int, long, float, and double. This means working with simple numeric values inside switch statements and instance of checks is now entirely natural and seamless. It's a small tweak, but it's going to massively clean up your everyday control flow logic. Finally, let's wrap things up with Section 4, the road ahead. Whether it's through permanent additions or exciting previews, Java 26 is truly a massive leap forward. Between permanent additions like the removal of applets and AOT caching for any garbage collector, to exciting previews like HTTP/3, lazy constants, and structured concurrency, the message from Oracle is loud and clear. Java is evolving rapidly to absolutely dominate the cloud-native landscape. So I'll leave you with this provocative final thought. Is your legacy codebase actually ready for modern enterprise Java? It might just be time to start auditing those final fields and preparing your architecture for the future. Thanks for joining me on this explainer, and keep building great things.